Good afternoon. We're here to talk about hydraulics. Our main areas of focus are going to be the history of it, how it works, some modern uses of it, and the future of hydraulics. Hydraulics is a topic in applied science and engineering dealing with the mechanical properties of fluids. Fluid mechanics provides a theoretical foundation for hydraulics, which focuses on the engineering uses of fluid properties. In fluid power, hydraulics is used for the generation, control, and transmission of power by the use of pressurized liquids. Hydraulic topics range through most science and engineering disciplines and cover concepts such as pipe flow, dam design, fluidics, fluid control circuitry, pumps, turbines, hydropower, computational fluid dynamics, flow measurement, river channel behavior, and erosion. Hydraulic machines are machinery and tools that use liquid fluid power to do simple work. Heavy equipment is a common example. In this type of machine, hydraulic fluid is transmitted throughout the machine to various hydraulic motors and hydraulic cylinders, and which becomes pressurized according to the resistance present. The fluid is controlled directly or automatically by control valves and distributed through hoses and tubes.
In 1785, an Englander named Joseph Bramah was working on a press. William George Armstrong, a contemporary of Bramah, was an industrialist and the founder of Armstrong Whitworth. Sir Armstrong is said to have found inspiration in a water wheel for his later engineering work while he was out on a fishing expedition. He noted that while the water wheel was doing much work, it was still allowing much potential to be lost. This lost potential, he reasoned, could be harnessed somehow. He first designed a rotary engine from the concept, but later moved it to an hydraulic piston type of design that could move a crane. At a time when the scientific field of hydraulics engineering was not yet recognized, Armstrong and Bramah were applying Pascal's laws to their inventions. Joseph Bramah got a patent for his invention for the hydraulic press in 1795. While arguments could be made that would place the use of a hydraulic engineering at a much earlier period in history, such as a claim that in the 14th century Somali tribes used water forces in agriculture, or that even thousands of years ago seafarers used oars as contraptions or lever to exert force on water, or that in the Greek Hellenic period writers were describing machines that made use of leveraged fluids and force pumps. But history has a well-marked the beginning with Bramah and Sir Armstrong. The history of hydraulic systems is found in dam design and engineering. It is found in the field of automobile, aviation, bicycles, and rail. It is found in military applications and space exploration, and in other disciplines where fluid circuitry is used, such as turbines, pumps, and hydropower. The history of hydraulic systems is found in the current development of the computer, where computational fluid dynamics is a buzz term.
Hydraulics are used in many ways. Car brakes work when you push the brake pedal, it pushes the small piston. The piston applies pressure on the brake fluid, which presses the brake pads on the large piston. The brake pads come into contact with the brake drum and slows the car down, eventually stopping the car. Airplanes and jet planes use hydraulics in many places. Hydraulics are used when adjusting the wings, bringing and putting out the landing gear, and opening and closing the doors. Bulldozers are machines that are classified as crawlers, which means that they move using continuous tracks or rigged plates joined to each other on a system of wheels. The purpose of continuous track movement is to distribute the weight of the machine over a larger surface than wheels are able to distribute. A bulldozer is equipped with a blade known as a dozer blade. Although the term bulldozer is often used to describe many kinds of machinery, its correct use describes only a tractor with a dozer blade. A backhoe is another piece of machinery that uses hydraulics in order to function. A backhoe is a type of excavating equipment often referred to as a digger. Essentially, it is a tractor fitted with a two-part articulated arm with a digging bucket on the end of excavation purposes. The arm nearest the vehicle is called a boom, and the second part of the arm is called a dipper. An arm and bucket are powered by advanced hydraulic systems that allow precision of movement.
When it comes to the future of hydraulic uses, there are 5 things we can do to make hydraulics better. Increasing energy efficiency. Current uses of hydraulics require a lot of energy. In order to advance the use of hydraulics, we must find ways to use hydraulics without using as much energy. One possible solution for this would be to have less equipment running and focus on the basic uses. Improving reliability. One way of improving the reliability of hydraulic machinery is to use components that will last longer and are less susceptible to break or fail. Building smart components and systems. Continue to innovate in existing machinery which will let us excavate with more precision and will be safer. Reducing size and weight. This will require better equipment with is both smaller and weigh less, reducing environmental impact. More precise excavating will be needed.
Hydraulics are a very important part of today's society. They allow us to do things that would require a lot of manpower and a lot of time. Free surface hydraulics is a branch of hydraulics dealing with free surface flow, such as occurring in rivers, canals, lakes, estuaries, and seas. Its subfield open channel flow studies the flow in open channels. Without hydraulics, we wouldn't have things like excavators, which help us get what would take a day to do in 15 minutes, because the power of hydraulics can get plenty of things done very quickly.